All right. Well, there's nothing like trying to be perfect. All right. Solving this, you see that you have two factors on this side and two factors on this side and two factors on this side. I need to move this factor to the other side. And just as if I had 2x minus 3 is equal to 4, if I wanted to move this one to that side, I would just do the opposite, right? So we remember that. I'm going to do the same exact thing here, except I'm going to do it factors. So x minus 2 times 2x minus 3 is equal to, put it in red over here, x minus 2, and I'm going to keep that red here because I want you to see that these, you have to recognize, oh, wait a minute, that's the same factor. And then x plus 5. What I'm basically doing is taking this and I'm going to subtract this factor on both sides, So I'm moving it over. So I want you to see that. Instead of writing all that out, I just need to go and say, all right, here's x minus 2 from the original factor on the left side times 2x minus 3 minus this from the other side. From there, I need to see, wait a minute, these two things I can factor out. I can bring this out and this out. I can factor out. In other words, divide out. That's going to leave me with this minus this. So x minus 2 factored out times the quantity 2x minus 3 minus parentheses x plus 5. On the inside of the green brackets, just add like terms. And so that's what this is going to be about. Distribute the negative in here and here, and you get 2x minus 3 minus x. Hello. Thank you. Okay, bye. Okay, so we're back. This produces a minus x and a minus 5 here. We still have the 2x, or rather the x minus 2 on the outside. We still have that factor. On the inside, add like terms. So I get x minus 2. 2x minus x is x. Negative 3 minus 5 is a minus 8. And this is all equal to 0. It's all equal to 0 because remember, we brought that over. This gets us back to the beginning of the lesson where our solutions are 2, 8. And that's how we use factoring and all the skills we've learned so far to solve this seemingly complicated equation. That'll do for this one. Okay, there are two more that I want to do in this set, and they're at the tail end of the lesson, 17 here. Number 10 says verify. So what it's really asking us to do is to verify that these two things are equal. So all we have to do in number 10A is to distribute, multiply these two together. So I'm going to use, remember there's 3 different ways I can do it, but I'm going to use distribution. So A times A plus 5 minus 5 times A plus 5 And it's got to equal, it has to equal a squared minus 25. So let's see. That's a squared. That's plus 5a. That's a negative 5a. And that's a, what? This is a 5, a negative 25. You can see that these two cancel out, and you're left with a squared minus 25. Does that equal a squared minus 25? Yes. So we have verified it. That's all we had to do. That's it. Practicing, multiplying. So again, we're reviewing. This is a review of multiplying polynomials. Okay, one more. So it says solve for x. So watch. This right here breaks into x minus 3 times x plus 3. Oops. This expression right here breaks into x minus 3 times x plus 3. In the previous problem, we showed that relationship. So if we were to multiply this back out, we would get that. I want you to start to see that this relationship exists between squares. 9's a perfect square and x squared is a perfect square. Look at the relationship. Spy and see if that makes sense. The reason why this is important because now we're going to move that over. Subtract equal to 0. Look, factor out. Add like terms. X, well, there's no more x, plus 3 minus 5 minus 2 equal to 0. And my answers, two solutions, 3, 2. So this is the last problem we're going to show. Again, solving by factoring. There you go.